variation. This procedure is dividing out the variation relative to our different treatments and to our different locations. If we start with, oh, good, you know, 50 minutes through the class, it's a good time to start. If we start by first looking at treatment, and I'm coming back to you, is there a difference between the treatments or are they similar? And that we can use the p-value to tell us. There's a difference. P-value is very small. There's a difference between treatments. Do we know what that difference is yet? Nope. Nope, we don't, not yet. Is there a difference between the locations? There's also a difference between the locations. It's a small p-value, not as small, but there's a difference between the locations. So far, so good? Paul? Yep. So the F value is the ratio of the mean sum of square differences for a particular variable relative to the error term, the residual. So this F value is literally the ratio of 7,400 over 400. And this F value is the ratio of 2,200 over 400. So in each case, each one of our factors has its own F value because each factor has a mean sum of squares and each factor is then taken relative to the overall error term, the error mean sum of squares. Great question. Cool? Yep. Ooh, I'm excited to be this next person. And that person would be Mateus. Because Mateus, I'm going to go up to line 24, and I'm going to write out a note that is going to be the result sentence as of this point. And we're going to make it two sentences. And Mateus, I'm going to ask you to give me a result sentence for location based on the information we have right now. I'm sorry, treatment. I literally, again, point to what I thought I was trying to say and I said the wrong thing. I want you to give me the result sentence for treatment based on all the information we have presently. Okay. There appears and I'll do this part because this is sort of like you just have to know the variables. And the number of millipedes found at, and I'll let you finish this part. We're doing treatment first, but you had the right idea. Okay, and I'll finish it. What do I need? What evidence do I need? Okay, what do I need for, if I'm doing a parametric test, I need three things. So what are the three things I need? Yep, I need the degrees of freedom, I need the test statistic, and I need the p-value. And it goes test statistic, degrees of freedom, p-value. So we're gonna write. Yeah, no, actually there is a reason it should be in that order. Because this is the mathematical equation that divides out the variation. Then how many degrees of freedoms do you have for this calculation? And that ratio of the test statistics relative to degrees of freedom is how you calculate the p-value. So you're literally saying, I did this first based on this amount of data I could work with, and this is my conclusion. That's the logic behind it. Great question. So F equals 15.4 degrees of freedom equal 1,112 P. So 0.001. So far, so good? Max, little esoteric question. Why am I reporting two different numbers as a degree of freedom? Why am I reporting both 1 and 120, 112? And you got so many people around you, like Mateus and Hector have not given you eye contact. Chloe's like, I am looking forward. Paul's mask is literally going above his eyes. Yep, yep. Great, great. So I want to make sure that's good. So the first one gives you a reflection of the number of groups. Remember, it is k minus 1. So it's telling us here that we have 2 groups, but only 1 degree of freedom. Because once we know the first one, we know the variation, we know that second number. The second one is actually giving a reflection of the overall sample size, which is your error. How each of the data points scatter relative to this overall pattern. So your first one is a reflection of the groups. The second one is a reflection of the data points, how many sample sizes you have. Each row, each row. Because you lose one here, right? You had 2, lose 1 there. You have 3, lose 1 there. You now have lost 1 more here. That's where you drop it down. Great question. Does that logic make sense? I really honestly don't know if I can, but I can try. Okay, so this is the number of treatments. It reflects the number of treatments, k minus 1. The second for location is also k minus 1. And then our residual is n minus k. So however many groups you have. You have 2 groups here, you have 3 groups there, so it's your sample size minus that. Lacey? I want my next result sentence. I want the result sentence for location. All right, treatment. All we know right now with treatment is there is a difference, small p-value. We know that location also has a small p-value. So I want a result sentence that tells us that information. Is this a small p-value or a large p-value? It's greater than 0.001, that is true, but normally our threshold is 0.005. So it is less than that. You know, you can see there is a difference, I'll say that. There is a difference. In this part, I'll just fill in for you the number. Millipedes found, and now you finish the rest of it. Yep. Get in the practice of clear, simple statements. Treatments seem similar, or treatments appear to be different. You can definitely use the word is. I kind of like more cautious terms, like appears to be, especially when we start to get around the threshold. The really small things, pretty clear. Okay? Kai, give me my evidence. Yep, love it. Great. Mm-hmm. What is that? Let me see the actual data. All right, so we have 116 data points. Let me take a break. I'm actually going to take a look and try to figure it out. Because math is actually, for me, seems like it should work out to 111. Yeah, but I must say that because you're only taking one away from location. So I'm off mentally by one. I want to take a look and figure out where that one's going. Elizabeth, did you have a question? So when we have a break, I will check for that. It is, but you only lose 1 degree of freedom. So it depends on, that's what I want to figure out. If it is the way Max just repeated, which is not what I meant to say, then that actually works. If it is what I meant to say, then I'm off by 1 degree of freedom. So I want to check one thing real quickly afterwards when we get a break. Questions so far? Okay, if there was ever a good moment to take a break, that is a good moment. Get out of here. I'll come back in a bit. Oh yeah, no. These type of tests, multiple variables, mixed model ANOVAs require sample size. If your sample size is too small, you cannot divide out the variation. And one way to sort of reflect that is your error starts to become small and you don't have any more meaningful information. So as an example, if we had only 20 data points, we couldn't do this test at all. Not a chance. There would be too few data to look at this complicated of a model, though you may be able to do like a t-test. It kind of depends on the overall effect size, how strong a particular variable is. I did adjust the p-values as I saw it. If I made a mistake, tell me. Oh, no, that's a great question. In this case, no. That's actually what this is doing. So instead of doing 3 separate tests, it's doing 1 test. It's just dividing out where the variation is depending on our first treatment, our second location, and the interaction. It's doing a test that examines treatment and location and interaction. So it's 1 test doing it all at the same time, where when we were doing a post-hoc test, it looks at the first pair, does that. Then it looks at the next pair, does that. And it does that for every single pairwise combination. Those are separate tests. That's why we penalize with the adjusted p-value. In this case, we are doing all of this analysis at the same time. We're identifying the overall, we're identifying the group effect of alpha, group effect of beta, and the interaction term all at once within 1 calculation. Adding extra variables will give you more information about the response, whether there's a significance or not, and you would be able to do it so long as you had a large enough sample size to divide out that variation. Great question. Any others? That's Elizabeth. Yeah, it's called a beta test, and it tells you the power you have in your data. And this is a very good thing to do when you first start like running an experiment. You get some pilot data, you do a beta test, and it will tell you the sample size you'll need to be able to show whether there is a difference or not. So the sample size you would be comfortable with estimating significance. Power test, beta test, those type of things. But you don't do that late in the study. You do that really maybe like you're doing a year-long study, you do it within the first month. You do it when you have maybe 10 or 20% of the data you're kind of thinking about getting. And then you do it so what you can see is this a good plan where I'll actually be able to show something? Great question. Any others? Okay. So I was going to have a plot, but we're not going to, because I want to move on to other things we'll be able to plot fiercely. You can do non-parametric two-way tests. So it's just you're ranking, I'm ranking, and there's just no justifiable reason at this point. So don't. Permutation tests. Really kind of straightforward. Permutation test, you don't have to test for normality. You still have to have independent data. You're evaluating the data relative to your distribution. You are using what are rattlesnake data from our campus. The study started 2015, 16, somewhere in that ballpark. And what you're looking at here is the size of the animals, what is called snout vent length, SVL, relative to their gender, male versus female, and their age, immature animals versus adults, where adults is defined as reproductive competence. They're able to reproduce. To do this, we need the package lmperm. Change the data to DF, obviously. And then we do want an extra function, which you don't have to have, but it's a good idea. And that is defining the method of permutation you're going to use. And we're going to use a probabilistic permutation. Rattlesnake. Oh, take a look at it. Anything that's not gender, age, and it's not vent length. Are you giving me crap? And I appreciate you. Thank you. Oh, yeah, right there. You added a pipe, which is a plus. So it was trying to mutate or do something with attach. You know what you wanted to do. So
There it is. Thank you.
you're very welcome.
Okay, I have a silly question. I forgot to add the probable on the first one
Mhm.
when I did it. So it's still doing as probable, like itself.
The default is capital PROB. So you got the same thing. You should be getting the same thing that we would be getting.
So, but I didn't. See how there's like slight variation. In
Oh yeah, but why is that?
Yeah. Why?
Tell me. That answer you can
Oh,
reason
wait,
out.
isn't this
The number of iterations it does. So your p-value always changes a little bit.
So even if I run it again.
Every time you run it, it will change.
I see. It just changes about. What are the bounds for the number of iterations?
Up to 5,000 is the default for LM firm.
Is that chosen? Is that random? Like from 0 to.
So yeah, it will be 1 through 5,000. The minimum tends to be around 30 to 50 because it needs to do some tests to see there's no pattern at all. But as soon as it resolves, it will stop. All right, tap up. So
Dr. Reynolds, will you do me a favor?
Mhm.
Will you take a picture with the alligator on top?
you have an alligator?
Well, it's a toy alligator.
Sure.
It's for my job.
I hold the alligator as a picture. Do I look at you for the picture?
You gotta pretend like you're wrestling it though. You gotta get into it.
You look so, yeah, I love it.
Yeah, spell it. Good job.
Maybe post it on the FAQ.
Oh, I was like, are they?
You have an error up on line 10. Okay, ladies and gentlemen, let's actually go through this. So I open up a new script. I'm going to save that as, and we're going to save this as rattlesnake. We'll save 2, a perm. We got that. That looks good. I've already loaded the packages. I've already loaded the data. Let's do that again so we could see it. I do summary. I get a bunch of information. There's a lot of data here. And if there are certain things you want to take a look at, you leave it in. But snout vent length tends to be a very good indicator of size. We're going to use that. So I'm only going to take out snout vent length, gender, age. Both gender and age are factors, so I define that. Age has a weird thing. R organizes categories alphabetically, alphanumerically. So A before B, D before X, 1 before 10. Sort of assumes that adjustment. Well, for our category of age, we have young animals and adults. A for adults is going to be positioned where we would expect to see the younger animals. So I'm going to use the factory level in order to readjust that position so that young animals come first and then adults. I run that. I do our summary. I do our attached. I'll quickly look at the summary, make sure everything looks good. I have snout vent length. Snout vent length is a number. I have gender. I have age. So we're looking good. We good with that? I'll leave that so you can still see those. I then have a model that's AOVP. The difference between ANOVA and the permutated ANOVA is just one letter P after you run LM perm. We have our model snout vent length by gender, age, and their interactions. The time sign gives us that. We're going to define our data, and we're going to define the structure for the permutation. This is the default, but I still like to write it in. Big heads up. If you put down a lowercase p, you are doing a parametric ANOVA. So if you type out prob with a lowercase p, you're going to get an F value. That's going to give you a parametric ANOVA. You do not want that when you're doing a permutation test. So either don't write out that line or make it a capital P. We run it. We get our results. Okay. ASPA. What have we learned about gender? That real borderline thing. So maybe there's no difference. Maybe there's a difference. It's borderline. It's confusing. That stinks. We don't like confusing, but it's definitely confusing. So we don't know quite what to do with age. How many iterations did we do? We did that test 1,376 times. Did you get the same number I got? Why not? Because it's randomized. So it's randomized until it resolves on a p-value. Did everyone get the exact same p-value that I got? No, you're going to get some variation. When it starts to resolve on a p-value. So when it starts to get at roughly 7% of the randomized tests are more extreme than what we measured. When it starts to see that multiple times, it's resolved. Yep. Yep. Not really, because this is pretty close to 0.5, 0.05. So how do we react when it's really close? Yeah, Sam just said, yeah, maybe. You know, you get a little squirrely about it. A really good thing to do in stats is not to be fixated on a particular threshold. You know, there may be a little difference overall. Okay. To increase statistical power? Yeah, more sample, more data. But never state that because it just means I'm too lazy to actually go do my job. So you use what you have. In some studies, there's nothing you can do. You know, I mean, these are wild caught rattlesnakes. There's only so many animals in the area. You test those, and if you can't find them, you can't measure them. Sam, I think I saw. Because they were newborn. I mean, really, this is what we're talking about. When, well, because I caught it young. Oh, sorry. Oh, it's the distance from the nose of the reptile down to the vent, the genitalia. Okay. Hector, what did we learn about age? There is a very clear difference between young and adult animals. Hector, do we care? Really? Yeah, but like, do we really care? We do not. Why not, Hector? That's a good answer. That's a tough answer. I mean, this is one where yes, there's a statistical difference, but as soon as you think of the biology, it's kind of a dot. Like, are babies bigger than human adults? Nope. Are baby snakes bigger than adult snakes? No. And that's what this time. We don't even need a figure to know that one. But yes, it is significant. We put it in there for two reasons. One, we want to look at the interaction, and two, we want to control for that variation. We have these animals, let's control for the variation in age, so we can really look at gender and look at the interactions. On that note, Paul, is there an interaction term? Yes, meaning is there a significant interaction between gender and age? Yep. Do you know what the pattern is? Sorry, I just don't, clearly. Yeah, do you know what the pattern is? Well, I don't. No, I don't know the pattern at all. Can we really easily look at the pattern by looking at the map? What would be the easiest way to look at the pattern? This one is a definite graph. Interaction terms, graph them. But is it really? This is 0.005, 0.01. They're pretty close. You know, that's what, 5/1000ths of a difference. It does randomize. And one of the things with permutation tests you really want to be careful of is sort of gaming it, because you can ultimately game it. The more you repeat, you might get something that sort of fits the narrative you want to say. Don't. You know, and that's the only thing I could say there. But is 0.01 a significant interaction? Yes, it is. Yeah. And the other thing to remember is we never end with a p-value. The size of the p-value ultimately doesn't matter. If it's 0 versus 0.01, those are pretty comfortable that there is a difference. Let's go figure out what it is, or an interaction. Let's go figure out what it is. Don't stop with a p-value. It just opens the door for further. A what? You can to see T apply for gender. You can to see T apply for age. And yes, you absolutely can do a group by function to separate out size relative to age and gender. You can. Let's just make a figure. Yeah. And if you wanted that code, I'll give you that code. But like I promised, I was going to give you a figure to make a more elaborate box plot. You're welcome. We're going to start doing that. So this is where we're going to end up. That's where we're going to end up. This is where we're going to start. Define your plot parameters. Define your aesthetics. Because ggplot2 is a grammar. So what we do is we put in a piece, create a piece, we look at it. Then we put another piece, create a piece, look at it. Remember, data needs to be changed to DF. Sometimes it works and I haven't figured out the logic of why. So I just put in DF. Yeah, and that's what I'm saying. I do, but every once in a while it works because every once in a while I'm not really paying attention and I'm just typing out and I just forget to put in the data and it works. And I have not figured out the logic of why. Sometimes yes, sometimes no. But you are right. Always just put it in. So we run our aesthetics. When you run your aesthetics, nothing happens. The first thing we're going to do is we're going to define the box plot. This is exactly what we did before. Notice I call out the variable snake length. That's our aesthetics. And now we're doing our first piece. And I'm just going to copy and paste this over to R, and you guys can look at it from there.
Does it make a difference if you just fill out your aesthetics?
Yeah, it would just yep, it would just flip the roles. It's how you want to visualize it. So we run this first piece. Gender, female versus male, snout bent length, young animals in coral, adults in blue, and that's looking good. One of the nice things about ggplot is that we're actually able to add in elements and pieces to get a better and clear representation of what we want. So I'm going to go back over here. Now we're going to actually fix our labels. Labes, snout bent length in centimeters, title rattlesnakes size is influenced by the interaction between age and gender. Our P, in fact, I'm going to change that ever so slightly. I'm going to copy and paste that over. I need to copy the plus. Kind of like piping, we need to have both parts. We're going to add a subtitle. You remember this /n, that just creates a line break in our title. So now we have a label, rattlesnake size is influenced by interaction between age and gender. We have our p-value underneath. If you want to, maybe you want to put a permutated ANOVA, or maybe you want to put interaction. Both are kind of nice. We're just making little adjustments here and there. Our y-axis is now more clear. It's not SVL. It's actually saying snout vent length. Our gender was fine before. It's still good, male and female. Let's make sure you guys can see that. Okay, and let's do one last little element today. Let's add in points. So this line right here is going to add points to our box plot. This is the character shape of that point. PCH stands for the character shape. We're going to put in our jitter dodge. And what jitter dodge does is it takes the point and it just moves it randomly to the left or the right if you use width. So we can sort of spread them out so they don't sit on top of each other. And we're going to add an alpha term of 0.4. In fact, I'm going to go up here. I want to add alpha to our box plots. So 0.8 there. Not sure I understand the question, Chloe. Oh, I added an alpha term to our box plot to make it a little bit more transparent. And I added an alpha term to our data points. I will try to stop moving this and get it stationary. There we go. So what, and we'll come back to this on Tuesday. We'll start here on Tuesday, but what this does, it allows us to create a box plot where the data points are represented within that box plot. So not only can you visualize the distribution through the box plot, but you can actually see what each individual measurement was. The reason we got rid of the outliers is because now putting in the data points, we are still representing those outliers, but we're representing now all the data as well. So if you remember outlier.size, -1, that gets rid of the outliers as a representation. Geom points puts back in all the data points, including in the outliers. Ladies and gentlemen, let's call it on that. Let's have a good weekend. I am going to, actually, we'll stop real quick. Let me ask you a question. I'm going to put up an assignment. Do you want it required and graded, or do you want it as optional? Mob rule by volume. I think before Thanksgiving, otherwise it's just obnoxious to give you guys homework during Thanksgiving. Wednesday? We could do it on Monday night after Thanksgiving. We'll make it required, but it'll be due Monday after Thanksgiving. So you don't have to do it over vacation if you don't want to. Guys, have a good day. It's gonna be required and it's gonna be due the day after Thanksgiving. Monday night. Thanksgiving's a holiday season for me. I'm gonna be eating the entire time.